Hello, today I will be talking about electron microscopy. So what is electron microscopy? Well, it's a type of microscopy with much greater magnification than traditional bright field microscopy. It provides nanometer scale resolution of cells and molecules, and it helps reveal fine structural details that are not visible with light microscopy. There are two main types of electron microscopy. There is TEM and SEM. TEM stands for transmission electron microscopy, and it is good for looking at flat images. SEM stands for scanning electron microscopy. It is good for looking at 3D images. So how does TEM work? Well, first, an electron beam is generated by the electron gun. That electron beam then accelerates through the anode, and thirdly, that electron beam passes through the specimen and loses energy as it goes through electron-dense regions. After that, the electrons pass through the objective and intermediate lenses, which magnify the image. Next, the image passes through the projector lens, which further magnify the image. Finally, the image is projected onto the fluorescent screen, where it is then displayed on a computer. So how does SEM work? Well, similarly to TEM, an electron beam is first generated by the electron gun and proceeds to accelerate toward the specimen. Next, the electron beam then scans the surface of the specimen, which causes secondary electron discharge. Next, the backscatter electron detector and the secondary electron detector pick up that secondary electron discharge. The backscatter electron detector picks up that secondary electrons that come from deeper regions of the sample, and the secondary electron detector picks it up from the surface of the sample for visualization of the topography of the sample. The detectors then convert the electron signal into a light signal, which is then amplified before the final image is projected onto a computer screen. So here's a real-world example of how electron microscopy was used. It was used to look at and see if an individual was infected with more than one pathogen at the same time. And it was able to prove that it was possible to see if you were infected by the two different pathogens at the same time, which is advantageous over ELISA or PCR, which can only detect one pathogen at a time. However, while it did prove that you could see these two at the same time, it was not an economical way of doing this kind of detection of pathogens. So some of the limitations of electron microscopy. First of all, limited tissue use. Only living specimens are not suitable for electron microscopy. Next, we also can get artifacts. So as we can see here on this slide, there's a tear in that slide, and so that can decrease the amount we can see here and decrease the amount we can draw from it. Thirdly, as I mentioned earlier, the costs are very high of electron microscopy. And here are the citations. Thank you.